Hello students, welcome to the topic differentiability. In this video, I'm going to discuss more number of examples on derivatives of implicit functions. In last video, I discussed definition of implicit function, explicit function, examples on that, and also how to write derivatives for y variable functions. In this video, I'm going to solve more number of examples on implicit function, and also you are going to learn what are the derivatives for inverse trigonometric functions. So this year in inverse trigonometric topic you learned that inverse trigonometric functions. Now the derivatives of these functions. Now first see the example on implicit functions. See the question. If x cube plus x square y plus x into y square plus y cube is equal to 81, then find dy by dx. Students, see this example is now implicit function or implicit equation it is. Okay, so first you have to identify, always whenever a question is given, it is what type of example. So first you know how to write the answer. First you write the given equation and differentiate this equation with respect to x variable. So the first term is x cube. It is function of x variable and a standard function. You know how to write derivative for x raised to 3. So here we follow to write the derivative of this x cube, x raised to n. Okay, so according to that x raised to n, it is written as 3 into x square. Okay, x cube derivative is 3 into x square plus now second term derivative. The second term is not addition, it is a product. Therefore, we have to follow here product rule. And also the third term is also product. So to write the derivatives of these two terms, we have to follow product rule. Okay, now first let me write the second term derivative using the product rule. So product rule, you know that we keep one function as it is x square and we differentiate the second term. Second term is y. So y derivative, you know that in last video you learned that what is a y variable derivative. It is dy by dx plus now y variable as it is y term, then x square derivative. So x square is a standard function, you know what is the derivative, 2x. So this completes second term derivative, that is using product rule. Now go for third term. So plus as it is. Now third term again using the product rule. First term as it is x and second term derivative y square. So y square we have to write using the formula y raised to n. We have to follow this and into dy by dx. So y square is written as 2y, okay, into dy by dx. So this is the y square derivative plus now y square term as it is product rule. Okay, the first term is over plus y square. Next x variable derivative, it is 1. So this is entire third term derivative using the product rule from here to here. Third term derivative using product rule. Next plus y cube function derivative. It is a single. It is not multiplied with any function. Okay. So therefore it is a single and standard y raised to n. Follow that one and write derivative. It is 3y square into dy by dx. This you should not forget because we are differentiating with respect to x and the function is y variable. So therefore we follow here composite. We first write the derivative following the standard formula and then into dy by dx. And equal to right side constant number, its derivative is 0. I hope you understood this differentiating the implicit equation or given example. Now in this equation, we have many dy by dx terms. See here, first one, second one, third one. So take the common and then find out the dy by dx answer. Okay, we have three terms taking the dy by dx common. Okay, so remaining terms I write as it is, that is first term 3x square as it is plus, so here I take the dy by dx common. When you take the common, so you put the bracket and write the coefficients. First term coefficient is x square, so write it. And here second term dy by dx, the coefficient is x into 2y, so this I will write as a 2xy product. Okay, and the third term dy by dx coefficient is 3y square, so write it 3y square and complete the bracket. I hope you understood how to, after taking common, how to write the terms. And remaining functions you write as it is. Here it is y into 2x, it is written as 2xy, and another free from dy by dx term is y square into 1, that is y square, and equal to 0. So next we want a dy by dx function. No, remaining terms you transfer right side. So these are the three terms, dy by dx free terms. So transfer to right side. Transfer these three terms right side. Okay. So if you transfer dy by dx as it is into bracket function as it is equal to, now if I transfer these three terms right side, so these terms signs changes. Plus 3x square is become minus 3x square, and plus 2xy is become minus 2xy, and plus y square is become minus y square. Okay, so next step is you can take negative common, otherwise you can keep the sign as it is. Just this product term transfer to right side, so then it become, you will get a dy by dx function answer. So transfer this bracket function right side, that is dy by dx become minus numerator as it is 3x square minus 2xy minus y square, I am not taking here common, then divided by, so write this bracket function in the denominator, because it is multiplied with the dy by dx. When you transfer right side, it goes to denominator of the right side, therefore it is divided by. So this function is now dy by dx function. That means the given implicit equation derivative of the given equation. I hope you got it. Now next see the second example. If sine square y plus cos of xy is equal to k, then find dy by dx. So this equation is now implicit equation. We cannot get here y is equal to function of x variable only from this equation. It is not possible. So therefore this equation is implicit now. So now we are finding derivative of this equation. So first you write a given equation, sine square y plus cos of xy is equal to k. So differentiate this equation directly. Okay. So now here identify this sine square y. Okay. It is sine square y means trigonometric function raised to n. Function raised to n, the function is trigonometric. Whatever variable, don't worry about the variable. First identify the function. It is function raised to n. Type you have to identify. Now first I write the you learnt in composite function so many times, you have to identify that one. So sine square y function is nothing but function raised to n form. So you know how to write a derivative for function raised to n. N into function, that is sine y, whole raised to n minus 1, that is 2 minus n is 1. So here no need of writing power 1. Okay, after that derivative of function, that is sine y. Okay, using function raised to n formula, 2 sine y into dy by dx, d by dx of sine y function. Okay, plus cos of xy, it is also composite variable, composite function it is, because it is not cos x, it is cos of xy. So therefore it is trigonometric composite function. So first we write the derivative for cos. So cos function derivative is minus sine variable as it is into d by dx of variable, that is xy. I hope you got it. How to write the cos of xy derivative. First we write cos function derivative minus sine and keep this variable as it is into variable derivative. Here also the same rule. Function raised to n. N derivative first, that is 2n into function raised to n minus 1. Then d by dx of function, that is sine y. Right side derivative now k, where k is a constant. So therefore its derivative is 0. Okay. So derivative is not completed because we have here d by dx of function 2 sine y as it is. Now sine y derivative. So it is a y variable function and a simple and standard function. So sine y derivative is cos y. So whenever the variable y, it is multiplied by dy by dx. When you write the derivative multiplied by dy by dx, that is sine y is nothing but cos y and dy by dx. And this plus into minus is become minus sine of xy as it is. Here we have the function derivative of x into y. Okay, now x into y means, I told you, whenever the function is product means product rule we have to follow. So here when we use product rule, we get a big expression or addition of two functions. So therefore use the bracket and write the derivative using the rule. So you know that product rule, we keep one term as it is x, second term derivative, that is y, it is dy by dx, plus y as it is, x variable derivative is 1. Okay, one function as it is, second function derivative, second term as it is, first term derivative is 1. So complete the bracket, that is equal to 0. Right side as it is. Okay, further simplifying, and this is product, no, 2 sine y cos y, function variable is same y, and it is the product of sine and cos. So what we can write this product, it is sine. Okay, let me write once again, 2 sine y into cos y and dy by dx as it is. Next is multiplying this function to the bracket, minus sine into xy into first term, that is x into dy by dx, and this minus into plus is minus, and function into this is nothing but sine xy into y is equal to 0. Multiplying to the bracket. Okay, here we have a dy by dx two terms, so take the common, and also transfer this non dy by dx term to right side, that is sine of xy into y. Transfer this to right side. Okay, so if I take dy by dx common, see here, first is 2 sine y cos y, that function it is written as sine to y, standard trigonometric identity, and minus, what is the dy by second dy by dx coefficient, it is x into sine of xy or sine of xy into x. So complete the bracket is equal to, so now I'm transferring this term right side, it become plus, minus is become plus, sine of xy into y. So this is simplification. So next is transfer this function right side. Okay, this bracket function you will get very easily dy by dx. So therefore dy by dx is equal to sine of xy into y numerator divided by, so this bracket function just write it in denominator. So it become minus sine to y minus sine of xy into x. So this is derivative of the given equation. I hope you understood the derivative of the given implicit equation. Now let's go to third example. If sin square x plus cos square y is equal to 1, then find dy by dx. So this is also implicit equation. So given that sin square x plus cos square y is equal to 1. So this is very simple equation. Differentiate this equation directly with respect to x variable. Okay, now this is a function raised to n again, but x variable, whatever variable, you don't worry, first identify the type of composite. It is sin square x means function raised to n. First we follow function raised to n and we write the derivative. So it is 2n into function as it is and power is 1. Therefore into d by dx of function, that is sin x. So this answer is written now following that function raised to n. Plus cos square y, again function raised to n, we have to follow 2 into cos y into d by dx of cos y is equal to 0, because one derivative is 0. Okay, further writing derivative 2 sin x as it is. Now derivative of sin x, it is a x variable function and a standard function. It is not composite, it is a standard. So and it is also single. So what is its derivative? Cos x plus 2 cos y. Now cos y. So here we have to write the derivative of this function cos y. No, cos y function of y variable. First you write the derivative for cos. It is a minus sin y, and whenever y variable function, it is multiplied by dy by dx is equal to 0. I hope you got it, how to write the derivative or derivative of this example. Now this product is a standard, so write sin 2x, and this is, if you take negative common, it is also become 2 cos y into sin y, so minus outside, and this product function is become sin 2y and dy by dx is equal to 0. So easily here you can find the dy by dx function. So transfer this sin 2x right side, minus sin 2y divided by dx left side as it is. So sin 2x become minus sin 2x. So therefore dy by dx is equal to, transfer this term right side, it become minus sin 2x divided by minus sin 2y, and negative negative get cancel. So it become dy by dx is equal to sin 2x divided by sin 2y. So this is the derivative of the given equation. So this example is important for 3 mark or 2 mark in the annual exams. So on implicit equation, usually 2 marks, 3 marks questions you may get in the annual exams. Remember students, sometimes maybe for 1 mark if it is a simple implicit equation. It is very rare, but 2 marks, 3 marks, more chance. So these are the problems on implicit equations or implicit functions. I hope you understood how to write derivatives for implicit equations. Now let me discuss the derivatives for inverse trigonometric function. So in this second PUC, in one of the topic you learnt about the inverse of trigonometric function, that is called as inverse trigonometric functions. You know there are 6 inverse trigonometric functions: sine inverse x, cos inverse x, tan inverse x, cot inverse x, secant inverse x, cosec inverse x. Now these functions derivative, what we get, so that you are learning, you may get in exam for 2 mark or 3 mark, write the derivative or find the derivative of the sine inverse x function with respect to x variable, or maybe tan inverse x, cos inverse x. Okay. And also you have to remember these functions answers, direct answers, means Now this is also function, no, you have to remember it's what is the answer we get. And you may get examples like a standard function and inverse trigonometric functions, maybe product form, addition form, division form. If these functions we have means, you know the derivative answer of these inverse functions, and we write the answer, derivative answer we write. Okay, so first let me see what are the derivatives of these inverse trigonometric functions. Derivatives of inverse trigonometric functions. The first function is find the derivative of sine inverse x with respect to x. Now first function is sine inverse x function derivative. Okay, now see the solution. First you take this inverse function as a y. Let y is equal to sine inverse x. Okay, now you know that whenever inverse function is transferred, it become trigonometric. So let me transfer this right side inverse function sine inverse to the left side. So it become trigonometric. That is, this implies sine y is equal to x. I'm not shifting this entire term. I keep the variable right side as it is x. Only I'm transferring sine inverse, or you know that if we have a inverse functions, then how to write the trigonometric functions. So sine y is equal to x we get here. Okay, now I differentiate this equation. Okay, I differentiate this equation, sine y is equal to x. So sine y derivative, you know how to write, y variable function cos y into dy by dx, and right side it is a standard x variable function, it is 1. Now we want dy by dx, no, so therefore transfer this cos function right side, you will get very easily dy by dx answer. So dy by dx is equal to 1 divided by cos y. Now answer is in y variable, you can say that cos y. Okay, so just you substitute or write this answer in terms of x variable. Y means sine inverse x. So left side what it become, d by dx meaning derivative, y means sine inverse x, and right side you will get derivative of that function. So dy by dx is equal to, okay, now see I am writing this cos y function in terms of x variable. So for this I am using identity 1 divided by, as it is I am using identity cos theta means root of 1 minus sine square theta. Okay, recall this, cos theta function is nothing but root of 1 minus sine square theta. So this identity we got it from the sine square theta plus cos square theta is equal to 1. From that standard we get cos theta means like this. Y variable is there, therefore cos y is written as root of 1 minus sine square y. And in this example we know the value of sine y. Here you can see that second step, sine y is x, so therefore replace it in this place x. Sine y is equal to x you take, you will get cos y is equal to root of 1 minus x square. So this function you replace it, so then it become 1 divided by root of 1 minus x square. So this is called, or this function is called, or it is inverse trigonometric function derivative, that is sine inverse function. Okay, that is d by dx of sine inverse x is written as 1 divided by root of 1 minus x square. What is this x? Variable of the inverse trigonometric function, square of this variable, that's it. 1 divided by root of 1 minus, what is the function variable? X, that is x square, square of that. So like this it is written. Now this is the derivative of the sine inverse x function. Okay, and remember this answer. If this function, if you get anywhere and you are writing the derivative of this function means this answer you have to write, 1 divided by root of 1 minus x square, like this. Okay, for example you are writing sin x answer as a cos x, no, in the same way this function answer is written like this, 1 divided by root of 1 minus x square. This is the derivative of this function. I hope you understood. Okay, now let me go for a second trigonometric function, that is cos inverse x. Find the derivative of cos inverse x with respect to x. Let y is equal to cos inverse x. All these remaining functions, same method of writing the answer. First you write the y is equal to cos inverse x and transfer, or this implies cos y is equal to x. Then you differentiate this second step or second equation, cos y. Cos y derivative is minus sin y into dy by dx is equal to 1. Now dy by dx to get, transfer this minus sign by right side, so it become dy by dx equal to 1 divided by minus sin y. Next line, dy by dx is equal to, now 1 divided by, now I convert this sin y function in terms of x variable, again using the same identity. Sin theta function is written as root of 1 minus cos square theta. Sin y means 1 minus cos square y, and we know the value of cos y, it is x. So therefore what is the sin y function become? Root of 1 minus x square, because cos y is x. Okay, so replace this sin y now by this term, we get minus root of 1 minus x square. So this answer is same as previous one, but negative is extra here. So this is the derivative of which function? Cos inverse x. Remember, here also this x is nothing but a variable, squaring of that. Okay, this x square is nothing but square of this variable. 1 divided by, or minus of 1 divided by root of 1 minus x square. So this is the derivative of cos inverse x function. Okay, next is derivative of tan inverse x with respect to x. Tan inverse x function. Same method of writing, y is equal to tan inverse x, and transfer this inverse function left side, or from this inverse trigonometric equation we get tan y is equal to x. Okay, and differentiate this one, or this equation, you will get tan y derivative is secant square y into dy by dx is equal to x derivative is 1, and then to get the dy by dx, transfer this product to right side. Dy by dx is equal to 1 divided by secant square y. Okay, dy by dx is equal to 1 divided by, now see students, secant square we have and tan y is equal to x. So now how to recall the identity means, secant square and tan we have a one relation, 1 plus tan square theta is equal to secant square theta. From that you will get secant square theta is equal to 1 plus tan square theta. Secant square theta is equal to 1 plus tan square theta. We have this relation. Like this you have to recall. Okay, you have to understand why we are using this identity only, because we have relation between tan y, tan theta and secant theta. Okay, like this we have relation. Y variable, so therefore 1 plus tan square y. Secant square y is equal to 1 plus tan square y. Now what is the tan y from this equation? It is x. Replace it. Here you replace. That becomes secant square y is equal to 1 plus x square. So now in the denominator, secant square y means you replace, because when tan y is x, then secant square y is nothing but 1 plus x square term. That is the meaning. Okay, tan y is x means secant square what we get? 1 plus x square. See, you even you can find out what is the secant square y using the triangle method. Draw right angle triangle, and angle is y. Now here in the second step, tan y is equal to x we have. So tan y is equal to x means it is opposite divided by adjacent. So opposite is x, adjacent is 1. So therefore here you mark x opposite side and 1 adjacent side. Now you find out hypotenuse. So using Pythagoras theorem, so this become root of 1 plus x square. Now define secant y. So secant y is given by hypotenuse divided by adjacent. That is root of 1 plus x square divided by 1. It is nothing but root of 1 plus x square. So squaring this, you will get 1 plus x square. So this method also you can use, and you can substitute secant square y in terms of x variable. So therefore, what is the secant square y? 1 plus x square. So from this, it is clear that d by dx of y, that is tan inverse x function, answer is this 1 upon 1 plus x square. What is x in this answer? It is variable of the tan inverse function x. This variable only it is squaring that one. So this is derivative of tan inverse x, 1 divided by 1 plus x square. I hope you understood what is the derivative of tan inverse x function. Now go for another function, that is cot inverse x. Find the derivative of cot inverse x. It is also same method. Let y is equal to cot inverse x. From this it implies cot y is equal to x. Then differentiate this equation. You know the cot y derivative minus cosec square y into dy by dx, and x derivative is 1. Transfer this right side, cosec square y, right side, dy by dx is equal to 1 divided by minus cosec square y, and then my dy by dx is equal to 1 divided by, okay, now what is the relation between cosec and cot? So we have this relation, cosec square theta is equal to 1 plus cot square theta, or in terms of y variable, cosec square y is equal to 1 plus cot square y. From this cot y, first second equation or second step, cot y is x, so replaced by x, that become cosec square y is equal to 1 plus x square. Or using triangle method also, you can replace cosec square y, you will get the same substitution, 1 plus x square. So here it become minus of 1 plus x square, that is 1 divided by minus of 1 plus x square. So this is answer or derivative of cot inverse x function. I hope you understood. Next function is cosec inverse x. Find the derivative of cosec inverse x with respect to x. So first take y is equal to cosec inverse x, and from this it implies cosec y is equal to x. Differentiate with respect to x, it become, you know the derivative of cosec y, minus cosec into cot, because of y variable, write into dy by dx. X variable derivative is 1. Now find out what is dy by dx answer from this. Transferring right side, dy by dx equal to 1 divided by minus cosec y into cot y. So next step is dy by dx, 1 divided by minus as it is. Now what is cosec y? We have to get the answer in terms of x answer, derivative answer. So cosec y from the second step, it is x. But what about cot y? When cosec y is x, cot y is how much? So here I use the identity cot theta is equal to cosec square root of cosec square theta minus 1. So cot y means root of cosec square y minus 1. Cosec y I know it is x, so therefore function is become root of x square minus 1. Even using triangle method, you can find what is cot y, taking this as a x angle, x number. Okay, now I replace, it become root of x square minus 1. So therefore, what is the derivative of cosec inverse x? It is 1 divided by x, means variable only. See here I am explaining the answer terms. 1 upon minus sign, and x means this x only, it is variable, and root of square of x means it is a square of the variable minus 1. Here I explained the terms in the answer. What is the x means? It is nothing but variable of the function only, x only. Okay. So last function derivative, that is secant inverse x, y is equal to secant inverse x, then secant y is equal to x. Differentiate this, it is a secant y into tan y into dy by dx is equal to 1. So dy by dx is equal to, transfer this product into right side, it become 1 divided by secant y into tan y. So next is 1 divided by, now secant y means x, tan y means, I use the identity tan theta and secant theta, it is root of secant square theta minus 1. So this identity we get it from the standard identity, 1 plus tan square theta is equal to secant square theta. 1 plus tan square theta is equal to secant square theta. So from that identity, 1 is transferred to right side, then tan square theta is equal to secant square theta minus 1. Tan theta means root of that. So in terms of y variable, the answer is written root of secant square y minus 1. Now secant y is x, replace it, x square minus 1. So here you replace it, it become solution, that is derivative answer. So it is also same as previous answer, but in that it is negative, here it is positive. Okay, I hope you understood derivatives of inverse trigonometric functions. And dear students, one more point is, one more important is, you write or make the note of all these 6 functions derivative answer in one side. Final answers you just write it. Sine inverse x function, d by dx of sine inverse x is equal to what? D by dx of cos inverse x, it is what? Like this you make the list. So further we, whenever these functions we get with the other functions, maybe product or addition, you know the derivative answers. Okay, now these are the standard functions and their derivatives. I hope you understood how to write the implicit functions derivative and inverse functions derivative. Thank you, students.